Hello, welcome to this tutorial on longitude and latitude. In this video, this is miscellaneous problem 1. So we'll be looking at this particular problem. A plane leaves an airport X 20.6 degrees east and 36.8 degrees north and flies due south along the same longitude for 8 hours at the rate of 1000 kilometers per hour to another airport Y 20.6 degrees east and 30 and theta degrees south. The plane then flies west to another airport Z for 8 hours at the same speed. Calculate to the nearest degrees: A, the value of theta; B, the latitude of Z. Take the radius of the earth to be 6,400. So in our solution, what we do is we sketch the diagram to see the location of those places on the earth's surface. We have the equator. We have the equator, which is 0 degrees. We cannot say north or east. Then this time around we need to get the longitude: 20.6 degrees east. This is longitude 20.6 degrees east. This is where X is, but on 36.8 degrees north. So we take this as 36.8 degrees north. So the plane leaves X here. That's it. That's the coordinate of point X: 20.6 degrees west and 36.8 degrees north. That's point X. Then the plane flies due south along the same longitude. It flies like this from here, this longitude, down to the south, okay, at the rate of 1000 kilometers per hour to another airport Y on the same longitude as X, but theta degrees south. So we have the theta degrees south here. This is theta degrees south. So we have our point Y here. We have point Y. If you take this as the center of Earth, you can see that we have an arc of a circle. We call the angular difference to be alpha degrees. So what we do here is we know the distance xy to be 8,000 kilometers. 8,000 kilometers, because the number of hours is 8 hours, and each hour it covers 1000 kilometers. So that's what the meaning of 1000 kilometers per hour. So the distance between X and Y is 8,000 kilometers. And since this is along longitude, it is along a great circle. The distance is along a great circle. So on that note, we will now look at xy is theta over 360 pi r, where r is the radius of the earth. So we then substitute to get this time around we are going to use alpha. And for your information, because they are in different region, this is north, this is south, therefore alpha is going to be 36.8 degrees plus theta degrees. This will help us get our theta at the end of the day. This will help us get our theta at the end of the day. So this is 8,000 is equal to alpha over 360 times 2 times 22 over 7 times 6,400. We are told to take the radius of the earth to be 2,400. I can easily make theta the subject of the formula here. Sorry, alpha the subject of the formula. Alpha will be 8,000 times 360 times 7 divided by 2 times 22 times 6,400. So if you do that, we are going to have it from our calculator to be 59 degrees. So we said we now come back here. Our theta will then be 71.59 minus 36.8 degrees. This is going to give us 34.79 degrees. And to the nearest degrees, we have it as 35 degrees. This is nearest degrees. So that's the end of the solution of the A part of the problem. Then we go to B part of the problem. The plane then flies west to another airport Z for 8 hours at the same speed. So it moves to this side. So we need another longitude, which means it flies along this latitude. So that's going to be, this point is Z, and this longitude is unknown. We can call it a gamma degrees, and we don't know whether it is west or east. So that will be determined later. So we can have this. This is a sector of a small circle, since the distance is along small latitude, so it's a small circle. And then also for B, our YZ is going to be 8,000 kilometers too, so that our YZ is theta. Let's not use theta A, that is the angle over 362 pi r cos theta degrees. This time around, this is the theta we are going to use. Yeah, that's our theta there. So when we substitute, we are going to have 8,000 is equal to the angle we are looking for over 360 degrees times 2 times 22 over 7 times 6,400 times cos 34.79 degrees. This is times cos 34.79 degrees. Sorry, let me rewrite this. This is 8,000 is equal to A over 360 times 2 times 22 over 7 times 6,400 times cos 34.79 degrees here. So that if we are to make A the subject of the formula, that's the angular difference between x and y and z, is going to be 8,000 times 3,000 times 360 times 7. Okay, this is over 22 times 22 times 6,400, then times cos 34.79 degrees. So from our calculator, we are going to have our answer as 87.39 degrees. So compared to this, from the diagram now, which means the angular difference here is 87.39 degrees. And in that case, it is as good as they are in different region, because it is greater than this. Has it been it is less than this, it would have been smaller. That means A now is gamma. Am I using gamma? Plus theta. So our gamma is going to be A minus theta. This is 87.39 degrees minus our theta, 34.79 degrees. If you press the calculator, we are going to have it as 66.8 degrees, and that's going to be west. So it's going to be west, and to the nearest degrees, we are going to have it as 67 degrees west. And that's all for the solution of this problem, and this is the end of this tutorial. Thank you for watching.